Hello students, in this video we will learn about the construction and least count of Vernier Calipers which is designed by Vernier in the year 1631. With the help of this device, you can measure length, internal diameter, external diameter, including depth of the hollow cylinder up to the value of 0.1 millimeter or 0.01 centimeter. Here, these values indicate the least count of Vernier calipers. This Vernier calipers consists of two scales. One is main scale and other one is Vernier scale. The main scale consists of the graduations from 0 to 1 and then 1 to 2, 2 to 3, each one 1 centimeter. Again in 1 centimeter, 10 smallest divisions are there. Each division value is 1 millimeter. So here this length indicates 1 millimeter in the main scale. And the second scale is a Vernier scale. It consists of a screw. With the help of this screw, we can move the Vernier scale on the main scale. This Vernier scale consists of 10 divisions from 0 to 10. This Vernier scale slides on the main scale. That's why this device is also known as sliding device. With the help of this Vernier scale, you can measure length and thickness, external diameter of the sphere and cylinder, internal diameter of hollow cylinder, internal depth of hollow cylinder up to the particular limit. In this device, two lower jaws are there. One is fixed to the main scale, another one slides on the Vernier scale. These two jaws are called as external jaws. With the help of these two jaws, you can measure the external diameter of sphere and also measure the external diameter of hollow sphere. And it consists of two more jaws. They are called as internal jaws. With the help of these two jaws, you can measure the internal diameter of hollow cylinder or you can measure internal diameter of test tube also. The Vernier calipers consists of a thin strip which is at the back side of the main scale, which is used to measure the depth of test tube or hollow cylinder. Now, we can calculate the least count of Vernier calipers. Here, least count means the smallest measurement that can be taken accurately from the device. Generally, every device consists of a fixed least count. It is mentioned on the device. If it is not mentioned the least count directly on the device, you can measure the least count from the formula. Is the value of one main scale division by total number of divisions on the main scale. I already told you the value of one main scale division is the smallest measurement, that is 1 millimeter. Then the total number of divisions on the Vernier scale is 10. From 0 to 10 divisions. With the help of these two values, you can calculate the least count. Is value of one main scale division is 1 millimeter divided by number of divisions on the Vernier scale are 10. Then you get the value as 0.1 millimeter. This value you have to convert it into centimeters divided by 10. That is 0.01 centimeters. Finally, the least measurement that can be taken accurately from this vernier calipers is 0.1 millimeter or 0.01 centimeter. Now, we will discuss about the zero errors in the vernier calipers. Zero error in the vernier calipers is a mathematical error due to which the zero of the vernier scale does not coincide with the zero of main scale. Let me show. In this vernier calipers, two scales are represented. One is main scale and another one is vernier scale. In this main scale and vernier scale, jars are in contact. The zero division in the main scale and zero division in the vernier scale are not exactly coincide with each other. That means the zero division in the vernier scale is ahead of zero division on the main scale. That means it is right side of the main scale. In this situation, we have to calculate zero error of the vernier calipers. Here, three cases are there. In the first case, the zero division in the vernier scale and the zero division in the main scale both are exactly coincide with each other. In this situation, the vernier calipers is free from error. That means error is zero. In second case, it is positive zero error. That means the zero in the vernier scale is right side of the zero division on the main scale. Such error is called as positive zero error. Now, you have to calculate the positive zero error. So, first of all, out of 10 divisions in the vernier scale, you have to identify one division is exactly coincide with any division on the main scale. Let us observe. First division is not coincide. Second division is also not coincide. Third division is exactly coincides. Here, coincidence point is equal to 3. So, this is the coincidence point. Now, this coincidence point, you have to multiply this coincidence point by the least count. So, the least count of the vernier calipers is 0.01 centimeters. That is equal to coincidence point 3 into 0.01 centimeters. That is equal to 0.03 centimeters. The value is represented by with sign plus. Plus indicates here positive zero error. Now, coming to the third case is negative zero error. Here also, when two jars are in contact, a slight variation is there here. The zero division in the vernier scale is left side of the zero division on the main scale, or simply it is outside the zero division of the main scale. Such a error is called as negative zero error. So, now we have to calculate the negative error. Here also, we have to identify out of 10 divisions, which division is exactly coincides with main scale division. Here, Vernier coincidence point is 5. That means the fifth division is exactly coincide. Now, first of all, before multiplying the value of 5 with least count, you can subtract this coincidence point from the total number of divisions on the Vernier scale. That is equal to 10 minus 5. That is 5. Therefore, zero error is equal to difference into least count. That is equal to 5 into 0.01 centimeters. That equals to minus 0.05 centimeters. Here, negative sign indicates negative error of the Vernier calipers. Here, you have to remember one important point. In positive error, we have to multiply the coincidence point directly with least count. But in negative error, before multiplying the number with least count, you can subtract that number into total number of divisions on the Vernier scale. Now, we will discuss how to take measurements followed by the calculations. So here, follow some steps. In step 1, you have to calculate the least count of the Vernier calipers. I already told you least count is 0.1 millimeter. In step 2, to find the zero error of the Vernier calipers. For example, here the Vernier scale and the main scale, fixed jaw and the movable jaw are in contact position. The zero division in this is the zero division. So the zero division in the Vernier scale is just ahead of the zero division on the main scale. Simply, it is right side of the main scale. In this situation, this error is called as positive error. To calculate the positive error, I already told you, first of all, identify the coincidence points. That means, out of 10 divisions, here, one division is exactly coincides. So, this is the division here. Out of 10 divisions, here, third division is exactly coincides. So, to calculate the zero error, this coincidence point multiplied by the least count of Vernier calipers as 0.01 centimeters. Finally, the positive error in this case is plus 0.03 centimeters. Here, sign indicates that error is a positive error. Now, in step 3, you have to calculate the diameter of the given sphere. First of all, the object should be placed in between the two lower jaws of the Vernier calipers. Those two jaws are called as here external jaws also. Now, slowly move the Vernier scale towards the sphere and tightening the screw. Now, we have to calculate main scale reading. The short form is MSR. Here, main scale reading is nothing but the position of 0 of Vernier scale. Simply, from which place Vernier scale starts. See here, the zero division in the Vernier scale is exactly at 3.5 centimeters on the main scale. Therefore, main scale reading is 3.5 centimeters. Now, we have to identify Vernier scale reading. Here, Vernier scale reading means, again, out of 10 divisions in the Vernier scale, one division only coincides with any division on the main scale. See here, so this division is exactly coincides. Therefore, Vernier scale reading is equal to fifth division is coincides. Therefore, 5 into 0.01 centimeters. Then you get the value as 0.05 centimeters. So that is vernier scale reading. Now we have two values of MSR and VSR, including least count and also positive error. Now how to calculate the diameter of given sphere? First of all, you have to calculate observed reading by the formula main scale reading plus vernier scale reading. You have to substitute those two values here, 3.5 plus 0.05 centimeters, that is equal to 3.55 centimeters. It is observed reading. But in this situation, it has some error. So, you have to calculate corrected reading by the formula observed reading minus of zero error. That is equal to 3.55 centimeters minus 0.03 centimeters. That is equal to 3.52 centimeters is the diameter of the given sphere. In some times, the same value is asking in terms of millimeters also. So the value is 35.2 millimeters. So the process is same for rest of the measurements also, like length, internal diameter and depth of the test tube. Children, you have to remember one point. To calculating the zero error, if you get the value of zero error as positive, then corrected value becomes negative. If error is negative, then correction becomes positive. So this is about the construction and working of the device Vernier calipers. Thank you, students.